Good evening and welcome to Dr. Dave's Molecular Adventures. Today we'll be looking at phosphate. Phosphate is a common molecule that is very important to life on Earth and can be found in an extremely wide variety of items. These include many different foods, both natural and processed, pool salts, and fertilizer. There is an even more vital role that phosphate plays in each of our lives, but first let's have a look at the molecule itself. Phosphate is a molecule made up of one phosphorus atom and 4 oxygen atoms, with the oxygen atoms being represented by the suffix -ate. The chemical formula for phosphate is PO4. Phosphate is a compound. This means that it is a pure substance that can only be separated by chemical means. The particular shape of the phosphate molecule is tetrahedral. This is because the 4 oxygen atoms want to be as far apart from each other as possible due to their similar charge, while still remaining centralized around the phosphorus atom. The angle between each of these atoms is 109.5 degrees along a relative two-dimensional plane. The phosphate is an ion, written as PO4 3-. This is because of the way that the oxygen atoms have bonded to the phosphate atom. This molecule is held together by covalent bonding. This means that the same electrons are shared between 2 atoms. In the case of these 3 oxygen atoms, they share 2 electrons with the phosphorus atom, one of which comes from the oxygen and one of which comes from the phosphorus. It is important to note that these 3 oxygens have also gained an additional electron, hence the 3- charge on the phosphate. The top oxygen is also held in place with covalent bonding. However, as you can see, it is not a single bond. It is what is known as a double bond. This means that 4 electrons are being shared between this oxygen, and 2 of which come from the phosphorus. Now I know what you're thinking, but now the phosphate has 10 valence electrons. And you're right, it does. 4 from the double bond, and 2 from each of the other bonds. Now usually, an atom only wants 8 valence electrons, but in this case it is possible for the phosphorus to have 10 valence electrons. Now, as I said before, phosphate is integrally important to life on Earth, and not only because it is found in food, pools and fertilizer, it is also found in DNA and bones. It is in fact one of the most important molecules on Earth, because without it, we could not possibly exist. Thank you for watching Dr. Dave's Molecular Adventures, and I'll see you next time.